Have you ever stopped to think about how an app like Discord manages to handle literally trillions of messages? Or how Netflix just knows what show you're going to want to watch next? Well, the secret sauce is often found outside of traditional databases. So today, let's dive headfirst into the world of NoSQL, a whole family of databases built for the absolutely massive scale and crazy complexity of the modern internet. And that's really the big question, isn't it? For decades, there was pretty much one type of database that ran the show. But as the internet exploded and applications had to serve millions of people all at once, the data they were handling got, well, messy. It became super clear that a one-size-fits-all approach just wasn't going to work anymore. All right, so here's the fundamental difference in philosophy. You've got your traditional SQL databases on one side. They're built on a very strict, predefined structure, a schema, and they scale vertically. That means when you need more power, you buy a bigger, beefier server. But NoSQL databases, they embrace flexible, dynamic schemas and scale horizontally. You just add more commodity servers to the cluster. And that right there is the game changer. To really get why NoSQL even exists, we have to rewind a bit and look at the exact challenges that pushed those traditional relational databases right to their breaking point. The internet boom brought a total tsunami of data. We're talking mind-boggling volumes of unstructured information pouring in from social media feeds, from Internet of Things devices, you name it. And all of a sudden, applications needed to be available 24/7 and scale out horizontally to handle millions of users, not just up. These were pressures the old guard just wasn't built to handle. And this is exactly where the NoSQL alternative steps in. Now, it's not one single product. You should think of it more like a new way of thinking about data storage, a philosophy, really, born out of the very practical needs of huge web-scale companies. At the heart of this new approach is a fundamental law of distributed systems, something called the CAP Theorem. It's actually pretty simple. It says you have three things you want: consistency, where every read gets the absolute latest data; availability, where every request gets a response; and partition tolerance, meaning the system keeps working even if parts of it can't talk to each other. Here's the catch. You can only pick two. Now, here's the kicker. In any real-world distributed system, network failures are just a fact of life. They're going to happen. So you have to be able to tolerate partitions. That's non-negotiable. Which means the real practical choice that engineers have to make every single day is between perfect consistency and constant availability. This trade-off leads directly to a completely different set of principles. Instead of the super strict ACID guarantees of relational databases, which, by the way, prioritize perfect consistency above all else, many NoSQL systems lean on something called BASE. So BASE stands for basically available, meaning the system is pretty much always up and responsive. Soft state, which means the system's state can change over time. And the big one, eventual consistency. This just means that if you stop making changes, all the copies of your data will eventually become consistent. It's a choice to prioritize uptime over having every single piece of data be perfectly in sync at every single millisecond. Okay, so now that we've got the philosophy down, let's look at the actual tools. Remember, NoSQL isn't one thing. It's a toolbox with four main types of databases, and each one is designed for a very different kind of job. First up, we've got the simplest and, a lot of the time, the absolute fastest, key value stores. Seriously, just think of this as a massive distributed dictionary. You have a unique key and it points to some value. That's it. Because they're so simple, they are incredibly fast, which makes them perfect for things like caching data with Redis or managing user sessions. Amazon's DynamoDB is another huge example of this in action. Next up in our toolbox, we have document stores. These build on that simple key value idea, but give you a lot more structure and flexibility. So instead of pointing to just a simple value, document stores like the very popular MongoDB hold these complex JSON-like documents. And the real beauty here is that every single document can have a completely different structure. You don't have a rigid schema. This flexibility is fantastic for things like content management systems, e-commerce platforms, or mobile apps where your data model is changing all the time. Okay, but what if you need to handle truly gargantuan amounts of data and query it super efficiently? Well, that's when you reach for a wide column store. Databases like Cassandra and ScyllaDB organize data into tables and rows, kind of like you're used to, but with a major twist. The columns can be totally dynamic for each row. These things are absolute powerhouses for write-heavy workloads and querying massive data sets. This makes them a go-to choice for big data analytics and large-scale IoT applications. And finally, our fourth flavor of NoSQL is all about the connections between your data. See, graph databases don't just store data points. They store the relationships between them as first-class citizens. Your data points are called nodes, and the connections are called edges. As you can probably guess, this model is a perfect, natural fit for social networks, recommendation engines, and fraud detection. Basically, anywhere the relationships are just as important, if not more important, than the data itself. Theory is great, right? But let's see how these choices play out in a real-world, super high-stakes environment. And this example just brilliantly illustrates that whole right tool for the job mantra. Let's talk about Discord. By early 2022, they were dealing with a scale that is just hard to wrap your head around. Trillions of messages spread across 177 different database nodes. Their existing system was buckling under the pressure. This was leading to unpredictable lag and maintenance that was becoming way too expensive to run. Something had to give. You know, their database journey really tells the story of how a company's needs evolve over time. They started with a flexible document database, MongoDB. But as they grew, they needed better write performance, so they moved to a wide column store, Cassandra. And then, most recently, they migrated again to ScyllaDB, another wide column store, to solve a whole new set of performance problems. Okay, the reasons they switched get pretty technical, but it all boiled down to one thing: lag. At Discord's scale, the way Cassandra organized data was making reading messages slow and expensive. Routine maintenance would actually slow down the app for users. And the worst part? The system would sometimes just pause for garbage collection. Think of it like a self-cleaning process. And that would cause these huge, unpredictable spikes in lag. The move to ScyllaDB fixed these problems, dropping their worst-case read latency from over 100 milliseconds all the way down to just 15. That is a massive, massive improvement. So that whole Discord story brings us right back to our central theme. There is no single best database. There's only the best database for your specific problem. So let's recap our NoSQL toolbox one last time. You've got key value stores for pure speed and simplicity. You have document stores when you need flexibility. You reach for wide column stores for absolutely massive scale. And you use graph databases for complex relationships. Each one is a specialized tool, and knowing which one to grab is a key skill in modern engineering. And that really is the ultimate question, isn't it? The choice between SQL and all these flavors of NoSQL isn't about which one is better. It's about which one is better suited for the scale you're operating at, the shape of your data, and the performance your users demand. Understanding these trade-offs, well, that's what separates good design from truly great design.